So we start with chemistry, and chemistry is defined as the study of matter, and so that's what we start with in chapter 1. So again, chemistry is the study of matter, but then the big question is, what is matter? Matter is anything that has volume, which means it occupies space, and has mass, okay? And so which means literally everything, okay, in this universe can be studied under chemistry because almost everything that we talk about has volume and has mass. There's only one thing that does not have either, and that is, yes, that's a question for you. Yes, vacuum. So vacuum is the only thing that has no volume or mass for that matter, and so we don't really study vacuum in chemistry. Chemistry is a really very old science. Okay, so just a little bit about chemistry in general. The old name of chemistry was alchemy, and later it got changed to chemistry. So over the last 500 years, alchemy has changed into chemistry. So chemistry is a really old field. It started maybe in Egypt, in China, in India. Who knows where it started, but it started everywhere. And then now, of course, it is still as global as it was before. It has been around for a long time in different places for different uses. So, for example, there was the Iron Age and the Bronze Age, which were defined by chemistry because Iron Age is dependent on iron as a metal, and bronze is dependent on bronze, which is actually a combination of two. It's a mixture of two metals, not combination, but a mixture of two metals. And then, of course, there was the herbal medicine, which um, all of these fields, by the way, that I'm mentioning was not really studied by chemists because there was no formal field as chemistry. It was all studied by other people like priests, like philosophers, anybody, women, medicine men, anyone, but they were not really formally called as chemists. But anyhow, so herbal medicine, which is how our modern medicine has been developed, is also part of chemistry. And then antibiotics were also discovered through chemistry, and then a lot of elements were discovered. Now, elements have been around for a really long time. It's just a matter of discovery, okay? And then, of course, there are some new elements that have been formed on Earth, but a lot of these elements have actually existed already, always on Earth. We just didn't discover them. A lot of the elements like mercury, like gold, silver, platinum, iron, copper, all of these have been around for a long time, and they were discovered also, okay, for a long time. However, a lot of the other elements like oxygen, for example, they were not discovered until a little bit later, okay, in during research. So anyhow, chemistry has been around for a really long time, and so it's an established field. Eventually, chemistry was branched into three fields: organic, inorganic, and physical. Organic covers everything, all the compounds that occur naturally. Now the definition has changed a little bit, but initially it was anything that occurs in nature, for example, in plants and animals, that would be considered organic. Inorganic would be anything that comes from non-living things like soil, water, and then physical chemistry is considered to be where you study the physical properties of substances. Now we're going to talk about all of these things a little bit, okay, as we go on. So don't worry about any of these terms if you don't understand them. Nowadays, chemistry has been branched out into several other fields because now it's grown so much, and it's possible that a person who's studying organic may not want to go to listen to anybody who's talking about physical chemistry because it's such a huge field now. And so chemistry is now branched further into analytical biochemistry, nuclear, carbohydrate, protein, so on and so forth. So it's really become very, very narrow in a way in its research, okay, and all. But otherwise, chemistry is still one of the biggest fields on Earth. You may want to go to this Chemical Heritage Foundation website. It's a nice website where you can get a nice historical background on chemistry. It has information on all the developments, history of elements, and then a lot of the chemists, okay, who've been involved in a lot of the chemistry. So this is a little bit of a history of chemistry as far as I'm concerned. My branch is organic chemistry, okay. And as far as general chemistry is concerned, by the way, we study a lot of physical chemistry in general chemistry and then a little bit of inorganic as well. One of the things about any kind of a science subject is that it is very factual, okay, which means it's fact-based, which means that we say that we can prove anything that we say, okay. If it cannot be proven, then it has not been scientifically done, okay. So in order to prove that you have something or that you have done something, there has to be a method to it. Okay, and the method should be followed by everybody, followed by all the scientists so that everybody's on the same page. That method is called the scientific method. Okay, and pretty much all scientists follow it. And even if you're not a scientist, you may still follow it. You just may not know that you're doing this. Okay, so in order for you to have a really good theory, conclusion, or anything, you have to follow the scientific method. The first thing in scientific method is observation. And observation is where you actually look for something that is going on. Now, a lot of us, live in this world, and a lot of us may just exist and not even see what's going on around us. However, there are a lot of us who also observe things, okay? And so we know what's going around us. We are very aware of what's going on, and one should be observant, and that is actually a mark of a good scientist, okay, that you observe what's going on around you. So observation is the first part of scientific method. If you don't observe anything, then you don't really have the desire to study anything. Anyhow, so once you observe something that's going on, then you develop a hypothesis and say, okay, I see what's going on over here, so I think this is the reason why this is happening, okay. And so you can develop your hypothesis. Once you have your hypothesis, then you have to do an experiment, okay, on it. And the experiment that you have to do is very systematic, and you should be able to repeat it. Not only should you be able to repeat it, but your peers should be able to repeat it as well. And that way you establish that your method was correct and the way your experiment was set up was correct, all right, and dependable and repeatable, okay. And so that is experimentation, and this is one of the biggest parts of any kind of a science field. Whether you do biology, chemistry, physics, astronomy, whatever you do, you will have to have experimentation in there. No science is complete without experimentation. So this is by far one of the biggest parts of the scientific method. Once you have done your experiment, then you have proven your hypothesis. Now, if your experiment does not prove your hypothesis, either you change your experiment or you change your hypothesis, okay? Either one of those things. So anyhow, once your experiment proves your hypothesis, then you can come up with a theory and say, okay, well, this is what I think it is, okay? And so once your theory is established and it has been established for a while and stood the test of time, then it becomes a law. Okay, so for example, the law of gravity, it has stood the test of time. We all know there is gravity. So then it becomes a law. Okay, now theory and law, they can be challenged. All right, just because it's a law does not mean that you can't challenge it. You can challenge it, okay, and you can change it if you want to, except that you should have a very good hypothesis and experimentation to go with it. If you don't have those, then you have no right to change the law or theory for that matter. So anything that you do in science can be changed, because if your experimentation changes, if your data changes, then of course your theory is going to change as well. Okay, and so what this means, for example, the law of gravity. Okay, and so if law of gravity has stood the test of time, which is all fine and great, but supposing something, a celestial event happens and something changes in the in the earth, then maybe gravity disappears. Okay, maybe it won't be there anymore. So we'll have to change our law at that point, our theory and our law. So things can be changed provided you have good experimentation. Okay, so that is a scientific method. Then let's talk about matter. Matter is actually what we study in chemistry. Okay, and so matter can be classified into three phases: gas, liquid, and solid. And this is nothing new. You have heard of these things before. So in gases, the particles are far away. Whatever there are whatever kind of particles, and usually you don't see a gas unless it's a colored gas, you don't see it. Okay, the particles in gas are always going to be in motion, and then the gases will take the shape of the container. So for example, we're sitting in this room and we have gas all around us, but we don't see it. And then of course the fact that we don't know what shape it is, because technically whatever shape the room is, that's what the gas will be in shape of. The particles are always in motion, and that is proven by the fact that if a gas has an odor, then you will smell it. Okay, for example, you can definitely smell cookies, all right, and that's because the aroma is coming. Okay, so that's gas always in motion. Okay, and then liquid are where the particles are closer than gas, the particles are still in motion, and the liquids still take the shape of the container. Okay, and then we go to solids, where the particles are really packed together. They're very close, they're static, they don't move as much, at least you don't see the motion going on. But the nice thing about solids is that you can actually mold them into a shape, okay, whatever you want. Gases and liquids cannot be molded into a shape, they take the shape of the container, okay, but solids can be molded into shape. So here is how we classify matter. Okay, now that you know that can be gas, liquid, and solid, matter can be classified further into two things, substances and mixtures. Okay, and a substance is a compound or an element. Okay, so a substance is further classified into a compound or an element. Now, an element cannot be broken down into simpler substances. So for example, if you have iron as a metal, you cannot break it down further into anything. You can break apart the iron atom if you want to, but it will not be iron anymore. Okay, and so element is like the most fundamental substance, okay, of anything. It's the purest thing possible. Combination of elements will give us compounds. One compound is still a substance because that one compound is still pure. So for example, water, which is a combination of hydrogen and oxygen, is still considered to be a substance, okay, because it can exist by itself. All right, so elements and compounds, these two are what we call substances. The other aspect of matter is mixture. In case of mixture, it means you have two or more substances, okay, in there. In the two or more substances in there, you can have two kinds of mixtures, homogeneous mixture and a heterogeneous mixture. A homogeneous mixture is when the mixture looks like one substance, okay, so which means that there is a little bit of a confusion when you look at a homogeneous mixture and a compound, because compound also is like one substance, okay, whereas a homogeneous mixture also looks like a substance. So for example, when you take a glass of water from your tap, you really don't know whether it's going to be a mixture or is it just a compound. Okay, we know now that water coming from the tap is not a pure compound. Okay, it's not just a pure substance. All right, it is actually a mixture of some other elements in there. So for example, water will have calcium in it, magnesium, carbon dioxide, little chlorine in there. But since you can't see all of those different things in there, it's considered to be a homogeneous mixture. The other kind of a mixture is the heterogeneous mixture, and in heterogeneous mixture, you can actually see that there are two or three different things or more, okay, different things. So for example, like a salad mixture, okay, so if you have a salad of lettuce, tomatoes, onions, whatever it is, that would be considered to be a heterogeneous mixture because now you can actually see different things. Fog, for example, is a mixture which is heterogeneous because you can see the air, and then of course you also have the water in there. Dust storm would be heterogeneous. Salad dressing would be a heterogeneous mixture. Homogeneous mixture would be the air in front of you right now, which hopefully is clear, and you can't tell, okay, that there is actually air. Tap water is a homogeneous mixture. Okay, so anyhow, that's how you classify matter into different categories, which you will have to classify for me, okay, in a quiz or an exam. So let's talk about the properties of matters now. Okay, we know that matter can exist as compound, element, mixtures, and so on. Anyhow, the properties of matter are two kinds. You have the physical properties and chemical properties. In case of physical properties, you are studying the property without changing the chemical identity of the substance. Okay, so for example, when you study a physical state, for example, like melting, okay, or boiling, that is just changing the temperature, okay, of the substance. You don't change the chemical identity of it. Okay, you look at the color of the substance, you look and see if there is any electrical conductivity or how it conducts heat. Those are all physical properties. You don't change the substance, okay, in that case. In a chemical property, however, you actually see how the chemical will change on reaction with other chemicals. All right. So, for example, if you burn it in oxygen, treat it with chlorine, what will happen? Okay, what will happen to that element? Will it change? So, both of these things are studied in chemistry, of course. Physical property, as we mentioned before, is what we do in physical chemistry, and then chemical property is of course the entire chemistry, where you try to react substances together and see what happens. This is how new substances are made. Then there is a little other classification where we have changes of matter, which means where you can change matter from one to the other. So there are two kinds of changes, physical and chemical. Again, physical change is something that does not change the chemical. Just like a physical property, the physical change does not change the chemical, which means it's usually reversible. All right. So for example, if you melt something like water, if you take ice and you melt it into water, you really have not changed the chemical nature. You still have water, which means you can go back from water to freezing it again into giving you ice. Okay, and so that is a physical change, okay, where you're just going from one phase to another phase, which means gas, liquid, and solid. A chemical change, on the other hand, will change the chemical into something new. And so this one is usually irreversible, okay, which means that you can only go back by another chemical change. Okay, so it is irreversible by itself. You have to do another chemical change in order to get it back. So in these cases, an example would be like rusting, where iron will rust into giving you iron oxide. So the iron will change its color from, say, the silver gray color to the orange color. When you burn something in oxygen, for example, candle, if you burn a candle, you're not going to get the candle back after it's burned. So that's a chemical change. So those are the changes that occur in matter. Okay, so properties of matter, changes in matter, they're kind of similar. And then we have some other properties of matter, and two words that you should know is quantitative and qualitative. How do we study matter? Okay, so quantitative study is where we study anything by using numbers. Okay, and this is something that you will actually use in the lab a lot more. I mean, we do calculations in our lecture also, but you will see that you deal with a lot of quantitative and qualitative things more in lab. All right, so quantitative is when you study something in numbers. All right, how much quantity is required to change from one to the other and so on. Qualitative is when you just study the properties. So for example, if you add something to something else, does the color change? Does it produce gas? So we're just looking at the quality of something. That is called qualitative study. And then we have two other properties. Okay, one is called the extensive property and one is called intensive property. An extensive property is something that depends on the amount of matter, hence extensive. Okay, extensive meaning depending on external things, okay, like amount of matter. So for example, the mass of any substance is dependent on how much you have. Obviously, if you have more substance, you'll have more mass. Same thing goes for length. Okay, and so if you have more substance, you probably have more length. Intensive property does not depend on the amount of substance. So for example, density of a substance, whether you have 1 gram of water or you have 1 kilogram of water, it doesn't matter. It will still have the same density. The color of the substance may also be the same. It's also an intensive property. So you can classify properties as extensive and intensive also. Okay, so that is another properties of matter. And that kind of brings us to the end of this first portion. And from here, please understand that you need to know the scientific method. You need to know the matter. What is matter? How to classify it into hetero and homogeneous mixtures. In the matter, you should be able to identify and say which is substance and what is a compound and what is an element. You should be able to identify those things. You should be able to tell me chemical and physical properties and changes. And if I give you a property, you should be able to tell me if it is intensive or extensive and so on. Okay. So that's the first portion for chapter 1.